Welcome back to the Art of Math, to another tricky algebra video. In this one we're going to go over nested square roots and how to solve them using the technique of equating parts. Alright, so here's our problem. We're asked to simplify the square root of 2 plus 3 times the square root of 5. What makes this ugly in the first place? There's a square root inside of a square root. So let's see how we might try to do this. So here's our first attempt. We're going to say that let this whole thing be represented by x plus y root z. That's our first insight, where x, y, and z must be integers. So what does that mean? That means if we can get numbers, let's say 7, 1, and 3, then this would be simpler because it would only have one square root, whereas this has two square roots. So we're going to try converting this into that form. So let's try to solve that. So first thing we're going to do is square both sides to get rid of this outside square root. So here, that's gone. And now we're going to square this thing, which I've done off to the side here. You can do this step by step, but if you've been practicing your expanding and factoring from the expanding and factoring videos, you should be able to do this fairly easily. So here's x times x, that's x squared. At the end, you're going to have a y root z times y root z. That's this y squared z. And then there's two ways of getting the cross term, which is xy root z, and that's why there's a 2 over there, 2xy root z. Alright, so this thing expanded or squared will be that. All I'm going to do is regroup this. So this is term 1, 2, 3. I'm going to group terms 1 and 3 together over here because they don't have the square root. This term, the second term, has a square root. So that's the insight. I've grouped terms 1 and 3 together and this term by itself. What's so special about that? Because remember, x, y, and z must be nice numbers. So this left part over here, which has to be a number, a whole number, not a whole number, so an integer. This part must be equal to this 2 over here. The 2xy must be equal to the 3, and the square root of z must be equal to the square root of 5. So the z must be 5. That's what this technique of equating parts is about. We're literally equating things after we've arranged them to correspond in the same form. So I've just taken these arrows and written them in a systems of equations form. So you have the 2 is equal to that part over here. The 2xy is equal to the 3, and the z is equal to the 5. So we can substitute the 5 over here and simplify this by dividing by 2. So we get these two equations. And if you think about it, there are no integers that when multiplied give you 3 over 2. So we failed. There's no integer solutions. So at this point you're wondering, what is the video about, since we just tried to solve this problem and we failed? Alright, let's stay tuned. Alright, so now we're going to go to number 2. So number 2, we have a similar problem except with different numbers. So we have 3 plus 2 root 2, and we're going to again try to set it equal to x plus y root z. Same deal again, we're going to square both sides. That's going to turn into 3 plus 2 root 2. So in the original problem we had 2, 3, and 5. Here we have 3, 2, and 2. So that's why we put the 3, 2, and 2 here. And we've just copied over our results from the first problem so I don't have to redo the algebra. So we've set these equations. And now if you take a look, well, first of all, let's simplify this one and plug in the 2. So we get these equations. So we could see that if you plug in 1 and 1 for x and y and put that in here, 1 plus 2 will be 3. So all of this will work out. 1 squared plus 2 times 1 squared is 3. Which means that we can simplify square root of 3 plus 2 root 2 as 1 plus root 2. Which is awesome because this is simpler. So what does this mean? This doesn't mean the technique doesn't work. It means in the first problem, the form that we tried to use, so this x plus y root z form, you cannot re-express this in that form. So perhaps if we had tried more terms, or maybe x times a square root, some other square root plus y times a different square root, or maybe we have 3 terms or 4 terms with different square roots. If we make the form more complex, maybe we could find a way of redoing that, re-expressing that. So these are basically bad numbers and you can't make it work. But the technique is always good. In other words, the corresponding parts technique is powerful and it'll tell you whether you can or can't do it. So let's try number 3. And number 3, I'm going to give you guys a hint, and we're going to try this form with 4 letters. W root x plus y root z. So let's try to make it work. We're going to square both sides. we're going to get 5 plus 2 root 6. Again, set it up as a systems of equations. So you have the 5, the 2 root 6. You could square it off by yourself and see that just like in number 1, this square root term must correspond to that. And basically run this on your own and see if you can get this to correspond to this. You'll have these systems of equations. And then now this part is 5, the wy is 1, and xz is 6. So don't get lost in the details. Remember what we're trying to do. We're trying to see if we can re-express this in that form. So after you square all the algebra, we're going to get these equations. Now you start here and see, hey, w and y equals 1. That makes this work. And that makes these just 1. So can we find x and z that sum to 5 and multiply to 6? Sure. Set them to 2 and 3. Which means that we can re-express this as root 2 plus root 3. If you're sort of not sure how, like if you're unsure, try squaring this back, which will give you a 2 plus a 3, which will get you that 5, and then you'll have 2 root 6s for that cross term. So you'll generate this back if you square it. So yes, we were able to do this. This 3 triangle dot thing is a mathematical way of saying therefore, so I just want to introduce you guys to that. So we don't have to write the word therefore. And so we were successful. What's the moral of the story? There's 2 things at play. We have the technique of equating parts, and we have the correct form to try. So if you pick the wrong form, you will not find a way of re-expressing it. So depending on these numbers that you're given and the form that you're trying, you're still going to want to use the equating parts technique, but you may or may not get it to work because some numbers cannot be re-expressed in the form of your choice. So don't assume if the first form you tried doesn't work that there is no form that works. All right, I'll see you guys in the next video.